Welcome back, 8th grade. Mrs. Avedian here. We're going to work on pages 18 and 19 now, which this is where you're going to really get your practice on scientific notation, aka writing these expressions with powers of 10. I'm going to do like we did on the other practice pages. I'm going to do every 5th problem with you so you have a decent number of examples, and you need to do the rest by yourself. So we're going to start with question 1 here. We have 8,000 and we need to write it as an expression with the power of 10, aka scientific notation. We're going to take our decimal place, our decimal point, which is right here. We are going to move it so that we have just the 8 on the left side of the decimal point. So 1, 2, 3 places we need to move that decimal point. So to write this in scientific notation, it's going to be 8.0 times 10 to the, I moved it 1, 2, 3 places. So 10 to the 3rd power. Okay. Let's go try number 5. Okay, here's our invisible decimal point over here. I need to move it so that it's right directly to the right of the 4,000 of the 4. So I need to move it 1, 2, 3 places. I'm moving it over to the other side. So I'm writing this as 4.0 times, because see there's our 4 point, and just writing 1 0, times 10 to the 3rd power. Proper scientific notation, because we only have one digit to the left. That is, a digit is just another word for a number. One digit to the left that is between 0 and no greater than 10, and then we're multiplying it times 10 to the 3rd power because we moved that decimal point 10 places to the left. Number 10. Ooh, we got a big one here. So I'm moving it from, it's home right over here, and I've got to move it 3 places. Then I got to move it another 6 places. Then I got to move it 9 places, and that would put it right next to the 4. So I'm writing 4.0. So I have 4.0 times 10 to the 9th, because I moved that decimal place 9 places. Okay, let's move it on up. Number 15. Ooh, we're going backwards now. What do you think we're going to do to that exponent if we're going in the opposite direction? What do we do to other numbers when we go the opposite direction on a number line? Okay, let's look at this. I've got my decimal point over here. I need to move it until it's on the right side of the non-zero digit. So I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Okay. So now I've got 5.0 still, because there's no other digits here, times 10 to the 9th, but I moved it the other direction. So I need to make it negative, 10 to the negative 9th power. Let's try another decimal on number 20 here. Okay. I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got to move it 10 places to get it right to the right-hand side of the non-zero digit, the first non-zero digit. So it's going to go over here. Oh, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So this is 6.0 times 10 to the 10th, but it's negative because it's a very small number. I'm moving that decimal place in the opposite direction. I just moved the decimal place this direction. Instead of up here on our big numbers, our giant numbers, the decimal point got moved this direction to write it in scientific notation. And now I can easily compare these numbers you know, I can see at a glance, oh, this is times 10 to the negative 9th. So it's very tiny compared to this one that's to the 9th power. And I can compare it to this one to the 3rd power, and I'm like, oh, that's quite a bit smaller than this one to the 10th power. Let's do page 19 now, which is just more of the same. And we're going to do every 5th one. So again, we're starting with our decimal point when we don't see one is right here to the right. And I'm moving it 3 paces. Then I'm moving it another 3, which is 6. Then I'm moving it another 3, which is 9. So I'm moving it 9 places to the left because this is a really big number. So it's 8.0 times 10 to the 9th. And 10 to the 9th. Let's try number 5. Again, really big number. There's no decimal point here, so it's right to the right-hand side. And I need to move it 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, 6 spots, 7 spots, 8, 9, 10 places to get it right next to that non-zero number. It needs to go right here. So I'm moving it all the way from here to right here, which is 9 places that I moved it. So this is 3.0 times, oh, I'm sorry, 3, 6, 9, I moved it 10 places. Get it right, get it right. 10 to the 10th. Okay. Let's go try. Number 10 is a really small number. I don't know why you would write this in scientific notation, but or as a power of 10, you could. Whatever. This is one of those big whatevers. The decimal place is right over here. We need to move it so that it's right next to that. And how far did we move it? We moved it 1, 2 places. So this is 6.0 times 10 to the 2nd power because we moved it 2 places. Now we get into those questions where we're moving them the other way around. Moving to the opposite direction. We've got a super, super tiny number here. Our decimal point is right here. We want it to be right to the right side of our first non-zero digit. So how far did we have to move it? We had to move it 1 place, 2 places, 3 places, 4 places, 5 places, 6 places, 7 places, 8 places, 9 places, 10 places, 11 places. So this is going to be 10 to the 11th power. But we went the opposite direction. We've got this decimal over here. It's a very tiny number, so this is a negative. And our non-zero digit there that's between 1 and less than 10, 8.0 times 10 to the negative 11th power. Then the last sample problem we are going to do is this one. We have our decimal point here. We need to get our decimal point all the way over here to the right of our first non-zero digit. So we know it's going to be 5.0 here, but how far did we have to move it to get it there? 1, 2, 3, 4, 5, 6, 7, I lost track here. 1, 2, 3, 4, 5, 9, 10 places, so it's times 10 to the 10th power, and it's a tiny number, so it's a negative. Negative. We have to be careful to have those negatives and positives in the right place. Okay, kiddos? If you have trouble, you need help, call me. I am here for you. See you on the 29th.